Hello and welcome back at the Link channel. After we got all the information about the wireless network concept, now we will dive in some configuration about this network. Some of us probably remember getting on internet using dial-up. Dial-up involved using your landline phone, where your landline phone was unavailable to make or receive calls while you were on the internet. Your dial-up connection to the internet was very slow. It basically means that for most people, your computer was always in one place in your home or school. Then we were able to connect to the internet without using our landlines. But our computers were still hardwired to the devices that connected them to the internet. Today, we can connect to the internet using wireless devices that lets us take your phones, laptop, and tablets almost everywhere. It's nice to have this freedom of movement, but it requires special and intermediary devices and a good understanding of wireless protocols. So what we will do in this module? In this module, we will configure a wireless LAN to support a remote site. We will configure a wireless LAN by using wireless controller to manage interface. We will configure wireless LAN to the VLAN interfaces, a DHCP server, and at the enterprise authentication. And as always, after we do all the configuration, the last thing that we have to do is learning about common troubleshooting in wireless configuration issues. So in this material, we will do the first two topics, and in the next video, we will go through the second topics. Remote workers, small branch offices, and home networks often use a small office and a home router. These routers are sometimes called an integrated router because they typically include a switch for wired clients, a port for an internet connection, and a wireless components for wireless client access. As is shown here in this figure, where is a Cisco Meraki MX64W device. And in the next figure, it is shown a topology where we have the physical connection of a wired laptop to the wireless router. Then this router is connected to a cable or a DSL modem for internet connectivity. These wireless routers typically provide wireless LAN security, DHCP services, integrated name address translation, quality of service, and as well as variety of other features. The feature set will vary based on the router model. And most of the wireless routers are ready to service out of the box. They are pre-configured to be connected to the network and provide services. For example, the wireless router uses DHCP to automatically provide address information to connected devices. However, wireless router default IP addresses, username, and password can easily be found on the internet. Just enter the search phrase default wireless router IP address or default wireless router password to see a listing of many websites that provide this information. For example, username and password for the wireless router here in this figure are admin. Therefore, your first priority should be to change this default for security reasons. To gain access to the wireless router configuration graphical user interface, you have to open a web browser, and then in the address field, you have to enter the default IP address for your wireless router. The default IP address can be found in the documentation that came with the wireless router, or you can search on the internet. And here in this figure, it shows that the IP address is 192.168.0.1. which is common default for many factors. A security window prompts for authorization to access the router graphical user interface, and here the word admin is commonly used as the default username and the password. Again, you have to check your wireless router documentation or search the internet for your device. So after you will be logged in your router, there are some basic network setup included that you need to do. The first thing is that you have to log in the router from a web browser, and after you log in, you open a graphical user interface. This graphical user interface will have tabs or menus to help you navigate to various router configuration tasks. It is often necessary to save the settings change in one window before proceeding to the other window. At this point, it is a best practice to make changes to the default setting. So after you are logged in, the first thing that you need to do is to change the default administrative password. So to change the default login password, you have to find the administration portion of the router graphical user interface. And here in this example, the administrative tab was selected, as you can see. And here is where the router password can be changed, or in some devices, such as one in this example, you can only change the password. The username remains admin or whatever the default username is for the router you are configuring. So you have to choose which password you have to use the next time you try to log in your router. And as soon as you change the password, the wireless router will request authorization again. And here, what you will do is you will enter the username and then the new password that you just changed, and then click OK. So after you will be logging now with the new password, what you have to do is to change the default DHCP IPv4 addresses. By changing the default router IPv4 addresses, it's a best practice to use private IPv4 addressing inside your network. The IPv4 addresses which is 10.10.10.1 is used in the example, but it could be any private IPv4 address that you will choose. Then what is you have to renew the IP address, because when you click save, after the changes you will do, you temporarily will lose access to the wireless router. So what you have to do, you have to open a command window and renew your IP address with the ipconfig renew command, as it is shown here. And the last step is you have to enter to the router with the new IP address that you configured to regain access to the router configuration graphical user interface, as it is shown here, and by using the password that you changed, and now you are ready to configure the router for the wireless access. So now we will go and configure some basic wireless setup. The first thing to do is to view the wireless LAN defaults. So out of the box, a wireless router provides wireless access to devices using a default router network name and password. Okay. The network name, it's called the Service Set Identifier, SSID. Okay, it's default. And you have to locate the basic wireless setting for your router to change these defaults as it is shown here. So you have to choose the name. You have to make sure if you want to broadcast this SSID, or if you don't want to be shown for the other users that can access your network, you can make it as disabled. And by this, the users that want to try to connect with your network, they have to type in. The next step that you need to do is to change the network mode, because some wireless routers allow you to select which 802.11 standard to implement. Here in this example, it shows legacy that has been selected. This means that wireless device connected to the wireless router can have a variety of wireless network interface cards installed. But today, a wireless router configured for legacy or mixed mode most likely support 802.11a and AC network interface cards. So after you are done with that, you have to configure the SSID. So we go here and at the network name, which is the name of your network, you have to choose which network, how it will be called. Here in this case is used OfficeNet for all three wireless LAN, where the third wireless LAN is not shown here. So we have three. The wireless router announced its presence by sending the broadcast advertising its SSID, since we selected enable, and this allows wireless host to automatically discover the name of the wireless network. As I said before, if the SSID broadcast is disabled, you must manually enter the SSID on each wireless device that connects the wireless LAN. And then what we have to do is configuring the channels. Because device configured with the same channel within the 2.4 gigahertz may be overlap and cause distortion, slowing down the wireless performance and potentially break network connection. The solution to avoid interference is to configure non-overlapping channels on the wireless router and access points that are near to each other. Specifically, channel 1, 6, and 11 are non-overlapping. And here in this example, the wireless router is configured to use the channel 6. And then, as always, you save the changes and then go to the next step, where the next step is configuring the security mode, because out of the box, a wireless router may have no wireless LAN security configured. And here in this example, the version of Wi-Fi protected access version 2 is selected, as you can see, for all three wireless LAN, because the Wi-Fi protected access version 2 has advanced encryption standard. So we at the encryption, we choose the advanced encryption standard, which is currently the strongest security mode. And then the last step that we do is to configure a passphrase, because the Wi-Fi protected access version 2 personal use a passphrase to authenticate wireless client. It's easier to use in a small office or home environment because it does not require an authentication server. Larger organizations implement Wi-Fi protected access to enterprise and require wireless client to authenticate with a username or password. And as you can see here, the passphrase is like when you try to access a wireless network, and you ask for the passcode. So you search the Wi-Fi and you have to enter the passphrase to access that wireless network. And after we have done all these changes, we have to save the changes that we just did. In a small office or a home network, one wireless router may suffice to provide wireless access to all the clients. However, if you want to extend the range beyond approximately 45 meters indoor and 90 meters outdoor, you can add wireless access points. And here as it is shown in the wireless mesh network in the figure, two access points are configured with the same wireless LAN setting from our previous example. And you can see here the channels that are selected are 1 and 11, so that the access point do not interfere with the channel 6 configured previously on the wireless router. Extending a wireless LAN in a small office or home has become increasingly easier. Manufacturers have made creating a wireless mesh network simple through smartphone apps. You buy the system, disperse the access points, plug them in, download the app, and configure your wireless mesh network in a few steps. Search to the internet for best Wi-Fi mesh network system and you will find reviews of the current offerings. And on a wireless router, if you look for a page like the status page as it is shown here in this figure, you will find the IPv4 addressing information that the router uses to send data to the internet. You see that the IP address as 209.165.201.11, as is shown here, is a different network than the address 10.10.10.1 address assigned to the router LAN interface. Because all the devices on the router LAN will get assigned addresses with the 10.10 prefix. This address that is listed here is an IPv4 address which is publicly routable on the internet. Any address with the 10 in the first octet is a private address and it cannot be routed to the internet. Therefore, the router will use a process called network address translation to convert these private IPv4 addresses to the internet routable through the IPv4 addresses. With network address translation, a private source IPv4 address is translated to a public address. The process is reserved for incoming packets. The router is able to translate many internal IPv4 addresses into public IPv4 addresses by using this network address translation. Some ISPs use private addressing to connect to customer devices. However, eventually your traffic will leave the provider's network and be routed on the internet. To see the IP addresses for your device, search the internet for what is my IP address. Do this for the other device on the same network and you will see that they all share the same IPv4 address. Network address translation makes the possibility by tracking the source port number for every session established by a device. And if your internet service provider has IPv6 enabled, you will see a unique IPv4 IPv6 address for each device. And as many wireless routers have an option for configuring the quality of service, and by configuring this, you can guarantee that certain traffic types, such as voice, and video are prioritized over traffic that is not as time sensitive as email or web browsing. On some wireless routers, traffic can also be prioritized on specific ports. And here in this figure, it's a simplified mock-up of a quality of service interface based on a Netgear graphical user interface. You will usually find the quality of service setting in the advanced menu. And if you have a wireless router available, investigate the quality of service settings. Sometimes this might be listed under bandwidth control or something similar. Consult with the wireless router's documentation or search in the network quality of service setting for your router's make and model. Because wireless routers typically block TCP and UDP ports to prevent unauthorized access in and out of a LAN network. However, there are situations where specific ports must be opened so that certain programs and applications can communicate with devices on different networks. And port forwarding is a rule-based method of directing traffic between devices on separate networks. When traffic reaches the router determines if the traffic should be forwarded to a certain device based on the port number found with the traffic. For example, a router might be configured to forward port 80, which is associated with HTTP. When the router receives a packet with the destination port for port 80, the router forwards the traffic to the server inside the network that serves web pages. Here in this figure, port forward is enabled for port 80 and is with the web server at IPv4 address 10.10.50, as you can see here. Port triggering allows the router to temporarily forward data through inbound ports to a specific device. You can use port triggering to forward data to a computer only when a designated port range is used to make an outbound request. For example, a video game might use port 27,000 to 27,100 for connecting with other players. These are trigger ports. A chat client might use port 56 for connecting the same players so that they can interact with each other. In this instance, if there is gaming traffic on the outbound port with the triggered port range, inbound chat traffic on port 56 is forwarded to the computer that is being used to play the video game and chat with friends. When the game is over and the triggered ports are no longer in use, port 56 is no longer allowed to send traffic of any type to this computer. The topology generation scheme used for the configuration of a wireless LAN on a wireless controller are as it is shown here in this figure, where we have the topology and the addressing scheme. The access point is a controller-based access point as opposed to an autonomous access point. Remember that the control-based access points require notional configuration and are often called lightweight access points because they use the lightweight access point protocol to communicate with a wireless controller. So it's access point and a wireless controller. Control-based access points are useful in situation where many access points are required in the network. As more access points are added, each access point is automatically configured and managed by the wireless controller. Configuring a wireless LAN controller is not that much different from configuring a wireless router. The big difference is that a wireless control access point and provides more services and management capabilities, many of which are beyond the scope of this module. So Here in this figure, it shows the login into the wireless controller with credentials that were configured during initial setup. The network summary page, that is a dashboard that provides a quick overview of the number of configured wireless network associated access points and active clients. You can also see the number of rogue access points and clients as it is shown here in this figure. When you click at the access point from the left menu to view an overall picture of the access point system information and performance as it is shown here, the access point is using the IP address 192.168.200.3. Because Cisco Discovery Protocol is active on this network, the wireless controller knows that the IP address is connected to the fast Ethernet 01 port on the switch. So we find this information here. The access point in the topology is the Cisco IronNet. (1815i), which means you can use the command line and a limited set of familiar iOS commands. And here in this example, the network administrator ping the default gateway, ping the wireless controller, and verify the wired interface. Most wireless controllers will come with some basic settings and menus that users can quickly access to implement a variety of common configurations. However, as a network administrator, you will typically access the advanced setting. And here for the Cisco 3504 wireless controller, we click at Advanced in the upper right hand corner to access the advanced summary page. From here, you can access all the features of the wireless controller. So let's go and configure a wireless LAN by using a wireless controller. A wireless LAN controller have ports and interfaces. Ports are the socket for the physical connection to the wired network. They resemble switch ports. Interfaces are virtual. They are created in software and are very similar to the WLAN interfaces. In fact, each interface that will carry traffic from a wireless LAN is configured on the wireless controller as a different wireless LAN. VLAN, sorry. Here we have a Cisco 3504 wireless controller that can support 150 access points and 4096 VLANs. However, it's only 5 physical ports, as you can see. This means that each physical port can support many access points and wireless LAN. The ports on the wireless controller are essentially trunk ports that can carry traffic from multiple VLANs to a switch for distribution to multiple access points, where each access point can support multiple wireless LAN. So let's do some basic wireless LAN configuration on the wireless controller by including this step. And the first thing we to do is to create a wireless LAN. And here in this figure, the administrator is creating a new wireless LAN. So you click at the tab wireless LAN, and then each of writing down the profile name of the wireless LAN that will serve as a service set identifier, and this ID is an arbitrary value that is used to define the wireless LAN in display output on the wireless controller. And then after that, we click apply, the network administrator must enable the wireless LAN before it can be accessed by users, as it is shown here in this figure. It has to enable checkbox allow the the network administrator to configure a variety of features for the wireless LAN, as well as additional wireless LAN before enabling them for wireless client access. From here, the network administrator can configure a variety of settings for the wireless LAN, including security, quality of service, policies, and other advanced settings. And when you create a wireless LAN, you must select the interface that will carry the wireless LAN traffic. Here in this figure, the selection of an interface, then this interface has already been created, the wireless controller. And then after this, you have to click at the security tab, and here you have to access all the available options for securing your wireless LAN. Here in this case, the network administrator wants to secure layer 2 with Wi-Fi protected access to phase shift key, which is a pre-shared key. And it sets the 802.1x as the default. And here in this layer 2 security drop-down box, we verify that the Wi-Fi protected access and Wi-Fi protected access to is selected, but it is not shown. And by clicking here at the phase shift key and enter a pre-shared key and click apply, with this we will be enabled to use the wireless LAN Wi-Fi protection access to pre-shared key authentication, where wireless clients that know this pre-shared key now can associate and authenticate with the access point. And after we created our wireless LAN, we have to verify that this wireless LAN is operating. So by clicking in the wireless LAN in the menu of the left to view the new configured wireless LAN, here, we click here, in the figure, you can see that we have a wireless LAN ID configured as 1, which is a wireless LAN name and which serve as an SSID, and we are using the Wi-Fi protected access to pre-shared key security. By clicking at the Monitor tab at the top to access the advanced summary page again, here we can see that the wireless LAN now has one client and it's using its own services. And when we click at the clients in the left menu to view more information about the clients connected to the wireless LAN, as it is shown here in the figure, one client is attached to the wireless LAN through access point 1 and was given the IP address as 192.168.5.2. DHCP service is the topology. In this topology is provided by the router. So with this, we are ending the first two topics about the configuration at the wireless LAN, and see you to the next section. If you are new to the channel, do not forget to subscribe and share it with your friends. See you soon.